Hello student again. Now we have in the last chapter, chapter 5, so we are going to talk about integration. The integration is the most important things, especially for those students that they want to continue to the Cal 2 or Cal 3, really in the Cal 2, Calculus 2, so you need really more information about the integral because you are starting with that subject, so please pay attention for it. Especially you are in the engineering student, so you need in your field. First of all, we start with the antiderivatives. Antiderivatives means that the derivative, antiderivatives, so the name is clear really, there's no meaning. Antiderivative, we have a derivative and you have an anti of this one. So why we say antiderivative? Because integral of x, for example, dx is equal to x squared plus 2 plus c. Because the derivative of here is equal to what? Is equal to 2x over 2 plus c is equal to x. So that's why we say antiderivative. So it means that antiderivative. That's why we say antiderivative. And you know the c will depends and will change with the indefinite integrals. Will change maybe 1, 2, 3, any number. That's okay. When we take the derivative, it will the result will be 0. That's why. So in that case, I'm going to start with the example. With here, you can see here's the antiderivatives. Means that if you have a integral of here, you will get n plus 1. If you have sine of k, you will get what? Derivative of sine will be done dx. Here's dx all. Derivative of sine will be minus 1 over x cosine dx, because we need the antiderivative here. Later I'm going to write this one for you as a alpha. With that one I will call it alpha. So how about this one? 1 over x. Integral of cosine will be sine. Why? Because the derivative of sine is cosine. Why we have a negative here? Because the derivative of cosine is equal to minus sine. Because there is no minus, that's why we put minus here. How about derivative of secant square? We know the derivative of tan is equal to secant square. That's why the integral of the secant square will be tan. How about the cosecant? Also we have a minus, we know, and it's a cotan. Secant tan, we know the derivative of secant is equal to secant tan. So the integral of secant tan will be cosine. That's why if you are controlling the derivative, really you can do it. Why? Because if y is equal to, for example, secant of x, you know the first derivative will be secant of x tan of x. Okay, so now I am going to say that if I have integral this one, you can directly say is equal to secant plus c. That's all. Okay, that's all. No more else. No more things. So just see this one. He talk about the antiderivative. Okay, so indefinite integral means that the integral without any boundary. There is no boundary, no numbers. Okay, so this is the means of the indefinite integrals. When we say definite integrals, here's definite integrals, we means that we have a boundary, upper limit and lower limit of integration. Okay, here. So indefinite integral in the page 2, section 5.1. What we have here we have how about this one? You know, we will, by this rule, by the first rule, we will add the power. So I'm going to say that this integral will equal to x to power 3 plus 3 and minus 2. X will be x squared over 2 and plus 5, and I'm going to put x here plus c, which if you have nothing, we have x. If you have 5, so 5 will go to plus c, of course. If I have 5, so 5 will go to the out and dx remains, and in that case I have 5x plus c. If I have x dx, I know it will be x squared over 2 plus c. If I have x to power 3 dx, the result will be x to power 3 over 3 plus c, and go on. Okay, that's why you get this result. How about page number 3? In the page number 3 we have well, he talked about the c, so okay, you can find the c, just don't forget about this solution. Here we have an indefinite, we said indefinite and definite. The indefinite was without number, definite is with the number. We have an upper limit integral and lower limit integrals. How about this one? For example, and we know if we have a, you can write down that. Okay, here's the function for continuous over. This is the theorem. He said that if you have a function and that they are continuous and there is no discontinuity on this here, you can, if you have a to b of any function, you can write down like minus. You can switch the boundary of the function like this dx, like for example 1 to 2 f, let the function be x square dx, I can say is equal to what? I can say is minus 2 1 in case we need it, 2 to 1 x square dx. How about AA? If I have 1 to 1 f of x dx, surely the result will be 0. For example, any function x squared dx, it will be 0 because there is no change. You know, the idea of the integral is the area. From, for example, when I say from 1 to 2, means that I want to compute this area. So if I say nothing, 1 to 1 means that I am staying here. There is no area. But I say 1 to 2 means that I want to find the area for this function f of x dx. This function, the curve f of x over the x axis. That's the meaning of definite integral. Okay. So how about so we finished the section 1. It's talking about the integral and solution, or how to solve the integral. For the next section, for the 5.2, here we are. We have another things here. It's talking about the section 5.2. It's talking about the rules or the theorems about the integrals. We say about that if we have AB, we can say BA. If I have a 0 because I have AA, that's the function. How about the constant? The constant, we solve some example coming to out, and there's the application of it. And if we have a sum, you can distribute the integral over what? Over the plus and minus. And if we have additivity, really you will use this one, especially in the area. Okay, especially in the area a b. So you'll change it. For example, if you have 1 to 2, you 1 to 3 u of f dx, you can change it to 1 to 2 f dx plus 2 to 3 f dx. That's the meaning of the additivity. And nothing about, forget about the number 6 and number 7. Just these 5 is very important in case for you in the Cal 1. So it's easy. And how about the number 3? For example, if I have 5 x dx, we say that the 5 will come to out. Why? Because a constant. So I have x dx, and then we will find the integral of this is equal to x squared over 2. Now it's time to solve these 3 examples. Really important because you need the time to deal with it, because the first time maybe for a long time you are not finding the integral, so it's a time to start. So if I have example 3, the page 4, section 5.2, the integral, he say that solve what part A from 0 to pi cosine x dx. First of all, how we find this one? First of all, I say the integral, forget about the boundary. I say the integral of cosine is equal to what? To sine of x plus c. But because I have boundary, we have a definite, so I am deleting this one and I am putting the value to 0 to pi. First of all, we should substitute a, then minus 5. How? I say is equal to sine, look, minus sine, look, here's the minus. The minus for what? The first, the upper, the second, the lower, and between them should be minus. This is the rule. Okay, so sine pi is equal to 0, 0 is equal to 0. How about the part B example? The same example, 0, pi over minus pi over 4, secant tan of x dx. We know the secant of tan will be equal to secant plus c. Instead of c, I have what? I have minus 4, 0. So we can substitute. How we substitute this one? We have a second minus second. Okay. So how about the value? I put 0, I put minus pi over 4. So the second of 0 will be 1, and the second of minus pi over 2, please go check the angles in the triangles in the chapter 1 that I give you the table which sine, cosine, and angles, especially in the angles in the first quadrant, you can see is equal to square root of 2. So in that case, we have the solution will be like that. How about the C? Let's see about the 1 of 4 to 4, 3 over 2, square root of 2 plus 4 over x squared dx. This example need more work because you didn't see this one for a long time. So as I say, we can divide 1 to 4, 3 over 2 dx minus 1 to 4, 4 to x cubed dx. Also, you can use another method. So, okay, I'm going to solve this one for you as a standard for those students that they haven't seen this for a long time. So it's time to solve this one. 3 over 2 will come to out, and it remains x 1 4. You can use it more gently, more quickly, and we say 3 over 2. And how about this one? I say 1 over 4 is equal to what? X 1 over 2 dx. So how we solve this one? I say that if there is nothing, we say 3 over 2, 1 to 4, 3 over 2. So time to solve this one. I say is equal to 1 over 2 plus 1 over 1 over 2 plus 1, because I say that if I have x, I will get what? X squared over 2. How? We add 1 plus 1, 1 plus 1. That's why. Okay, 1 plus 1, 1 plus 1. That's why we get this number. So how about the solution in this part? This part, we are just solving that part. So I say is equal to from 1 to 4, do not forget that, is equal to 3 over 2, and equal to what? Equal to first of all, x to power 3 over 2, here's over 3 over 2, 1 to 4, okay, is equal to 3 over 2, and 3 over 2 will come to 2 over 3, x to power 3 over 2, 1 to 4, do not forget about that, and is equal to 1, 4 to power, okay, 4 to power 3 square root 1 to 4 is equal to 4 to power 3 is equal to 8 minus 1. Okay, we put 4 to here, so 4 3 2 and 1 3 2 is equal to 8 minus 1. Okay, dear, that's the result. How about the second part? The second part of this, we have what? I'm going to write it minus, okay, 1 to 4, this one, 4 x to power minus 2 dx. I bring it to up, I bring it here to up, so 1 over x squared will be what? Will be changed to the x minus 2. So it's equal to minus, the 4 will come to out, 1 to 4 x minus 2 squared was equal to minus 4. This one will be x minus 2 plus 1 over minus 2 plus 1 from 1 to 4 again, which is equal to minus 4. In the down we have a minus 1, in here we also have a minus 1, 1 to 4. How about minus? This minus will change to the positive, and it remains 1 over x, because minus, I know, from 1 to 4 was equal to, I'll put the 1 over 4 minus 1 over 1. Why? Because I substituted the upper minus, we substitute the lower. So it's equal to let me see, it's equal to what? 4, the common denominator, so 1 minus 4, okay, Okay, something wrong here. I forget really 4, this 4, and also we have a 4. I have a 4 here, so it remains what? It remains plus 4 minus 3 over 4 was equal to 4, just minus 3 remains. So I have 8 minus 1 is equal to 7, and the result will be 4 minus 7 is equal to 4. I solve it in this method, so and your book solve it in another method. Do it quickly, so short. So please try to use this one. I forget this minus 4, do not forget about that. Minus to call plus, minus multiply minus will be to the plus, but I forget to put the 4, so 4 outside, and that's all the result we have. About the total area. Now in the page 4, it mentioned here total area. Total area. Area is very important application of the integral. So the one of the integrals application is the area, how to find the total area. So the total area is also used by integral. So they are very easy, but it needs more. It needs one point that you should be very careful. But I am going to mention it here. In the total area, for example, we have what? Example has 6 page 4 section 5.2. You see that f of x is equal to x squared minus 4. So a find integral over minus 2 and 2, and the area number b. B is to say that find the area between this time. First of all, let me do the x minus 4. So here's x squared minus 4, right? X squared minus 4 has x squared minus 4. It means that here minus 4, and we have 2 and minus 2 here. So he say that find the area of here in this region, all of them. Okay. So how we solve this example? You can see here. You can see in this example. So how we solve this example? We see that f of x solution. F of x between minus 2, we say area is equal to the integral between a to b. So here's the rule: area is equal to a to b. F of x dx, that's the rule. AB. So AB we have what? AB minus 2 to 2. F of x is what? Is x squared plus 4. Okay, dx. So it's equal to x cubed over 3 minus 4x between minus 2 and 2. Which the result will be what? The result will be, we put the, I'm going to solve it like a book. So first of all, we will substitute 2 to each x, okay, then minus here, okay. So I put 2, that'll be blue. We say 2 to power 3 over 3 minus 2 multiply 2, okay. So first part minus, here's the minus, the second part was equal to minus 2 to power 3 over 2 minus 4 multiply minus 2. So the first bracket will equal to, or the result of this bracket also, all of them is equal to 32 over 3. Try to do this easy, because you can do this easy, just numbers and multiplication. So in that case, we got something, area is equal to minus 3 over 2. What about minus? Why we get the minus? Why the result was the minus? We got minus because our area is under, here's the x-axis, it's the under x-axis, here's the area, that's why. So for passing this one, we put the absolute value, and the result will be what? The result will be 32 over 3. The area will be 32 over 3. So we cancel the minus, because we need the area, we don't need the minus. The area should be positive. But why we got the negative? Because as I mentioned in the before, as under the x-axis. How about the example 7? We have the same thing. We need this. It's very important. Sine. What we have a sine between 0 and 2 pi. So say find the area. We mentioned the b. Find the area over this time. So I'm going to solve it in a wrong way, because if you don't do this mistake, we cannot learn how to deal with the area. So in that case, the sine will be cosine of x. Sine will be minus cosine, sorry, and the result will be 0 to 2 pi, because it's definite, and we get cosine to 2 pi, and minus also minus cosine of 0. So in that case, we get what? Cosine 2 pi is equal to is equal to 1, and there is a minus 1, and minus will be plus. Cosine of 0 is equal to 1. So minus 1 is equal to 0. But the sign here from 0 to 2 pi will take the half area. What happened? Why we got 0? Because there's an area. So where is it gone? So no, there's no going to anywhere. This positive part is equal, this positive a1 is equal to a2. But because we have negative here, we don't put the negative value, we don't put the absolute value to this a2. That's why this minus cancelled that one. So the a1 is positive area and the a2 is negative area. Okay, so in this one cancel that the other. That's why we see we have no area. But in the real life we have an area. So how we deal with this one? How we solve this one? First of all, because the sine of x is between, he say find between pi over 0 and pi over 2. We should say sine of x should be 0. So find the value of x that's equal to 0. Then that make the sine to 0. Find the value of x that makes sine of x to be 0. Then you can control the area. That's why I say the additivity property is important in 5.2. I will mention this one later. I will mention this one later. Additivity property. So now we have x is equal to 0. But where x will be 0? If it's x is equal to 0, please try to use in the chapter 1 the table and the unit circle that I gave you, that you already had, and x at 0 will be sine of 0 will be 0, means that x to be 0. So sine also in pi will be what? Will be 0. So it means that x equal to pi. So also sine of 2 pi is also equal to 0, means that x to be 2 pi. But we know this one is the boundary, the end points. End point. How about this the middle, or inside or interior points? We will take this one. How? We say from 0 to 2 pi, f of sine of x dx. We will change it to additivity. 0 to pi, pi to 2 pi, sine of x dx, sine of x dx. After changing this one, we need what? We should find the absolute value. If I got the negative value, I'm changing it to the positive value. So now, if you want to solve you need the correct answer. The correct answer is like that. Area from 0 to 2 pi sine k x dx will change it to absolute value from 0 to pi sine of x dx plus absolute value again, pi to 2 pi, okay, pi to 2 pi sine of x dx. That's all. So in that case, we will get what? Sine of x, is equal to cosine of x, okay, between what and what? Between 0 and pi, okay, and in that case also again we'll change to the minus cosine of x between pi and 2 pi, okay. Don't take the absolute value quickly, just be patient. So this one equal to what? Minus cosine pi minus cosine 0 plus again minus. So sorry, minus will be changed. Okay, minus cosine 2 pi minus cosine pi. Am I right? Look, I put pi here, minus 0. 2 pi here, minus pi. So in that case, absolute value remains, okay, the cosine of pi is equal to -1. And we have a minus equal to +1. Minus cosine of 0 is equal to 1. So plus cosine 1. Okay, so we got what? 2. How about here? Cosine 2 pi is equal to 1. So we get -1. Plus minus equal to plus cosine of pi is equal to -1. So in that case, we got what? We got 2 plus -2. Am I right? So I got 2 plus 2 is equal to 4. That's the area of the real area of the sine. So the sine will take, here's the error, here's the solution that you shouldn't do it, here's the additivity, and here's the area after taking the absolute value. Okay, dear? So the summary, write the summary to find over x-axis. Subdivide means that use the additivity property, and where's the equal to 0, because here when it's equal to 0 means that you are here. This one for positive, this one is negative. We need to take an absolute value. Okay, that's all about the activity. So you should find the 0. This function is where is equal to 0, where's intersecting the x-axis. The last example will help you to summarize all things, because maybe there's we mentioned a lot of things here, but after this one you will summarize this example. After this example you will summarize that subject. Example 8 in page 6, section 5.2. You say that f of x is equal to x cubed squared 2x minus 1, into x, where x between -1 is that you have a -1 and 2. Okay, how we solve this one? So first of all, I'm going to take this one to be 0, so I take the x as a common, x minus 2 remains. Okay, and also I know this is the can be factorized between two using two brackets, x negative positive, so 2 1. So now how many zeros I have? You should tell me. 0, okay, 2 minus 1. You know how to do it. So we have these 3 points. So careful, where's the function is positive, where's the function is negative, you should tell me. We read this one. We know how to deal with that one. If you don't know, use the test point. Okay, use the test point, -2, 0.5 by minus, for example, 1, 3. Use the test point. You know how to recognize the positive or negative. So if I put negative, but here's the value. It is between what? You see, find between -2 and 1. So we don't need that points. We just need to test these 2 points. Why? Because we need the area between -1 and 2. So that's why we cancel the test point here. So how about here? If I put minus 0.5, here's negative, here's positive. So negative, positive, the result will be positive. So it means that the area is positive. A is positive, it's upper here. Okay, how about if I put 1? If I put 1, I will get positive. I put 1, I get negative. I put 1, I will get positive. So positive, negative, positive, negative. So it means that area under the curve. So I am taking the value here. And how we subdivide it? We say from -1 to 2 x cubed minus x squared minus 2x dx will be changed to -1. You should tell me. Minus x squared minus 2x dx plus we changed from -1 to what, to 2. So here should be what, 0. Do not forget about 0 is our -1 to 0, 0 to 2. Okay, that's why. So and this one we know this is the negative part. We should take what you say, the absolute value. So the result of this part, you can do it, and the result of this part will be -8/3. So after this, you know, I'll get plus, and the result will be, that's it. Here I think it's not difficult if you just follow the my instruction, and you can see here why we use the area, or how we use the area, how we find the area, and how we fix the area if it's negative under the x-axis. That's all about 5.2. I'll see you in the next video. We're still going to talk about something else between area between two curves and substitution methods. Thank you for watching.